Hey Algebra 2s, here's a key to last night's homework. When I want to solve the system algebraically, I'm going to take a look at each equation. These are both quadratic, and they're both already solved for y. So I'll go ahead and set each equation next to each other. Because it's quadratic, I'll solve it by combining like terms and moving everything to one side of the equal sign. That's going to give me 3x squared minus 3 is equal to, here's a 0 pair, there's a 0 pair, 0. I see a greatest common factor that I can cancel out. So I'll go ahead and take out a 3, leaving me with an x squared minus 1 is equal to 0. Because it's an equation, that 3 ends up not mattering. And I can go ahead and just look at my x squared minus 1 is equal to 0. I see the difference of two perfect squares. So I'll call that x plus 1. And x minus 1 is equal to 0. Therefore, my x is equal to plus or minus 1. Remember, we're solving a system, so now I'm going to go ahead and take these values for x and substitute them in to my equations to get my values of y. Either equation works out fine. You get to pick which one you want. My y is equal to 2 times 1 squared plus 1. My y is equal to 3. For my second solution, my y is equal to 2 times negative 1 squared plus 1. So that same y is equal to 3. Therefore, my solutions are positive 1, 3, negative 1, 3. If I wanted to see what these solutions look like on the graphing calculator, I could go ahead and graph each equation. 2x squared plus 1, the opposite of x squared plus 4. When I go ahead and graph, I can take a look at my solutions and I can see that makes sense. Positive 1, 3, negative 1, 3. I could also look at that horizontal line 3 and see that that intersects. My table of values offers me another choice where I can again look for solutions that are the same in all of the equations. So positive 1 and negative 1 both have here solutions of 3 and solutions of 3. All right, taking a look at number 2. I have 2x squared plus 2x plus y minus 36, x squared plus 10x plus y minus 52. I can go ahead and eliminate the y. I'm going to make this equation negative by multiplying each side by negative 1. When I add the equations, I'm left with 1x squared, negative 8 x's, and negative 36 and positive 52 is 16 is equal to 0. My y's canceled out because they were a 0 pair. When I look at factoring, I wind up with a special pattern. X squared factors into x times x. Negative 4 and negative 4 multiply together to give me 16 and add together to give me 8. Therefore, x is equal to positive 4. Here's the tricky part. I have to substitute this back into an equation and solve for y. I'm going to choose my original equation before I multiplied everything by -1. So 4 squared plus 10 times 4 plus y minus 52 is equal to 0. 16 plus 40 plus y minus 52 is equal to 0. 16 plus 40 minus 52, 4 plus y is equal to 0. Y is equal to -4. My solution is 4, -4. Alright, when we look at our next problem, y is equal to x squared and y is equal to -x squared plus 2. Because each of these are set equal to y, I can set them equal to each other. X squared is equal to -x squared plus 2. When I add x squared to each side to combine like terms, I get 2x squared is equal to 2. Because it's a quadratic, well, I'll go ahead and I'll take the square root of each side. After I divide by 2, x squared is equal to 1. So when I take the square root of each side, my x is equal to plus or minus 1. When I go solve for y is equal to x squared, so y is equal to 1 squared, y is equal to 1. Y is equal to -1 squared, so y is equal to 1. So the solution for this equation is positive 1, 1, -1, 1. Alright, when I look at this equation, I'm suspicious of the 3 and the 3 and the 9. So I'm going to go ahead and divide this entire equation by 3. I have -x squared minus y plus 3x is equal to 0. And I have, for my second equation, y plus 2x minus 4 is equal to 0. I'm going to go ahead and add these equations together because my y's are a 0 pair and we can have them cancel out easily. I'll rewrite both equations. -x squared minus y plus 3x is equal to 0. And I have positive y plus 2x is equal to 4. My y's cancel out. The opposite of x squared plus 5x is equal to 4. Because it's a quadratic, I'll go ahead and set everything equal to 0. The opposite of x squared plus 5x minus 4 is equal to 0. I'll factor out a -1, making each of my signs opposite. So now when I go to factor, I have an x and I have an x. When I get 4 times 1 that are both negative, I get a product of positive 4 and a sum of -5. X is equal to positive 1, x is equal to positive 4. When I go back to solve for y, I know that y plus 2 times x minus 4 is equal to 0. Y plus 2 minus 4 is equal to 0. So y is equal to 2. My next solution of y is going to be y plus 2 times 4 minus 4 is equal to 0. Y plus 8 minus 4 is equal to 0. Y is equal to negative 4. Therefore, my solutions are 1, 2, and 4, negative 4. Alright, let's check out this next one. When I go to solve this equation, I notice my y's are a 0 pair, so I'm wondering, well, not quite, because I have 23 of them here and negative 1 there. So I'll go ahead and I'll multiply this equation by 23. I have negative 4x squared plus 23y's plus x minus 101 is equal to 0. Then I have negative 23y's. I have plus 23x's plus 69 is equal to 0. That gives me negative 4x squared. My y's cancel out. Plus 24x plus minus 32 is equal to 0. I'm going to factor, so I'm going to pull out my greatest common factor. I'm going to take out a negative 4, leaving me with positive x squared minus 6x plus 8 is equal to 0. When I'm going to go ahead and factor, I have x and x. I know they're both minus. So two numbers that multiply together to give me positive 8 and add together to give me negative 6 are going to be minus 2 and minus 4. Therefore, x is equal to 2 and x is equal to 4. When I substitute back in, I think I'll choose this equation. That seems the easiest. So I'll go ahead and put in negative y plus 2 plus 3 is equal to 0. Negative y plus 5 is equal to 0. 5 is equal to y. Negative y plus 4 plus 3 is equal to 0. Negative y plus 7 is equal to 0. 7 is equal to y. Therefore, my solutions are positive 2 and positive 5 and positive 4 and positive 7. Alright, last one for this page. I think I'll go ahead and do linear combination. Because these are both linear, it doesn't matter whether I cancel out x or y. I'm going to go ahead and get rid of x's. That gives me 4x plus 3y is equal to 3. Negative 4x minus 2y is equal to positive 6. 1y is equal to 9. When I go to substitute that in, 4x plus 3 times 9 is equal to 3. 4x plus 27 is equal to 3. 4x is equal to 3 minus 27 is negative 24. Divide by 4. Divide by 4. X is equal to negative 6. Therefore, my solution is negative 6, positive 9.